My name is Brian Steckler. I'm the director of the Hastily Formed Network Center at the Naval Postgraduate School in Monterey, California.
I am the program manager of the evaluation of an advanced 3D printing machine that creates building framing materials from cold formed steel.
Cold formed steel is very easily shippable. It's very compact. It's a roll about 5 feet in diameter and about 2 feet thick and about 6 to 18 inches wide. So one roll can print out a building of about 16 foot by 32 foot in a matter of a half a day. Wood is hard to get in many countries. For example, the earthquake in Haiti, there was great difficulty just getting wood in the country.
The Navy Construction Battalion 1, currently deployed to Okinawa, Japan, has been assigned the task of testing the capabilities of this cold formed steel machine, since they will be the type of team to use the cold formed steel system when it becomes operational and in the field.
This is cold formed steel machine. In the back here we have the decoiler, where the steel is in a roll and it is decoiled back towards the machine. The machine tells it anytime that it needs a lip cut, any kind of dimples for screws, exactly where holes need to be. While the steel is still flat, it goes through here. You can have a cut for your service holes. You can have cuts for your electrical. You can have cuts so the steel goes together easier for screwing. After you get your service holes cut, the flat piece of steel continues through and it starts going through rollers. Now each one of these rollers bends it a little more. So as it goes through and it bends it a little more at a time, the sides come up until it's in a complete C. Once it gets into the complete C, it continues through and there's a lip put on the top edge in this area. After that, it goes through and a label is printed on. The label is basically just telling it, what it's for. Is it a wall? Is it a truss? And what piece of the wall it is. And then at the last station, it cuts off your desired length. Over here, we start putting the pieces together to form whatever it is, a wall or a truss, whatever it is that we need. Put it together.
Yeah, that's short. This stud. Put it in.
So after we put it together, stand the walls up, screw the walls together with self-tapping screws, using anchor bolts to anchor it down to the existing concrete. After the walls are complete, we move to the roof where we swing our trusses up, use L brackets to anchor them down so wind doesn't come by and blow them off. And then you have your roof panels that go on last. After that, you sheet the roof and sheet the walls.
A building made out of cold formed steel with the amount of screws and fasteners that we put on the building can withstand close to 200-mile-an-hour winds. It'd be very difficult to build a wood-structured building that could withstand 200-mile-an-hour winds. You can do it, but you're going to be putting more and more wood in and more fasteners in to get that strength. The main sponsor of this project is the Navy Expeditionary Combat Command. NECC hired Naval Postgraduate School, me and the Hastily Formed Network Center to manage the evaluation of this product.
My name is David Maiano. I'm the Force Strategy Director for Navy Expeditionary Combat Command. Some time ago, the Marine Corps asked the Naval Construction Forces to look into the potential for light gauge steel construction. Private industry has been using light gauge steel construction for many years now. Therefore, we started to dive in deeper to this capability. We commissioned an operational assessment for the cold formed steel mobile factory. The NMCB-1 out of Gulfport, Mississippi is the air det that is performing this task. Preliminary data indicates that there is a potential for a decrease of 2/3 the amount of time required to be on station, and also a decrease of half the forces required from after action reports that have been reported in past years. NECC commissioned the Naval Postgraduate School to conduct a business case analysis and return on investment. We also commissioned the Systems Engineering Division of NAVFAC Expeditionary Warfare Center in Port Hueneme to perform the operational assessment. So far it has gone very well. Obviously, the assessment is not complete. We are still in preliminary stages, but the results that we are finding lends itself a tremendous capability in bringing the naval construction forces into the 21st century.
This morning when we put our first wall up, that wall took every bit of 30 minutes. Normally that wall would have took about 4 hours to form up with lumber. So being out in the field, we can set these at every spot that we have a battalion located. They can pump out steel for any building that needs to be put up anywhere within that location. So we don't have to carry this machine everywhere we go. We can put it in one spot and just pump out buildings, pump out dimensions, whatever you need. Before, for us in the CBs, everything was lumber. So the time that it would take us normally to do a job is cut well in half now. The other problem we was having with lumber was we would use the local population lumber that they would have, and 3/4 of it would be no good. With this cold form steels, everything right on site. We no matter what size the building is, if we need to improvise, change something, it's all right there at our fingertips. We do a lot of jobs that people want, and we've been using what we call Flintstone technology to do Jetson's work.
We've got a couple students from the NPS Business School conducting a cost-benefit analysis and a business case analysis. So they're observing how it's being used in the field by the CBs and working in conjunction with Navy Expeditionary Warfare Center to evaluate the metrics, to record and evaluate the metrics of the use of this system.
What we traditionally do with a business case or cost-benefit analysis is look at the monetized effects of a system and compare those against the status quo. And like I said, the status quo being wood frame or concrete block construction. We're going to collect data on site for a little while longer, but the biggest thing to keep in the back of our minds is to provide decision makers with objective and dispassionate analysis, especially in this time of fiscal austerity. Being able to take that academic side and marry it up with the actual operational side of the house is a great way for me as a student to come away with how everything meshes together, so that when I go on to my follow-on assignment at Headquarters Marine Corps Programs and Resources, I then have a baseline for how to conduct my job.
How long it takes to build a building, how much material it takes to build a building, how many fasteners, how many screws, how many people, how many minutes it takes to build a building, how the machine works in intense heat and humidity. We're measuring a variety of different factors. So the whole purpose here is to show the art of the possible.
In only 3 days, the CBs were trained and able to reconstruct and retrofit buildings. Now they're able to construct an entire 16-foot by 16-foot building in just a few hours. This cold form steel system will have a very large impact on the ability of the Navy to rapidly provide humanitarian assistance with these new age construction systems.